Hey, it's Roger here, creator of the Azure Sandbox. I'm back. We're working on provisioning our first Terraform configuration, VNet shared, and we're going to pick up here at getting started. So the first thing we need to do is open a bash terminal. We already had one open, so we're going to pop that open here. And we're going to log out of Azure. And we're going to clear all of our cached credentials. And then we're going to log in. Now, when you log in from the CLI, you're going to get prompted to log in from whatever the most current browser session you had open. So make sure you're using the one that's associated with the account for your Azure subscription. So this is the account that I'm using for my Azure subscription, and I'm successfully logged in. So when we go back to the terminal here, you can see that I've got a single subscription that I have access to. Now, that's a little artificial because most companies will have many Azure subscriptions. So what we want to do is make sure that we avoid the rookie mistake of provisioning stuff on the wrong subscription. So what I'm going to do here is I'm going to go get a list of all the subscriptions that I have access to. And I'm going to output that list to a table instead of JSON. So I have just the one subscription I have access to. And I'm going to grab this subscription ID and copy it by right-clicking. And then I'm going to set that as my default subscription. Let's paste in that GUID. Now, it was already the default subscription since I only had one, but the way I've designed this is the automation assumes that the default subscription for the currently logged in Azure CLI user is the one that you're going to be using to provision the sandbox on. So you'll probably see multiple ones in this list. You just want to make sure you choose the correct subscription when you set your default. Another thing to mention here, the login experience for the CLI that I experienced, which was, basically from WSL on a Windows 11 machine, there's all kinds of different authentication flows that you could experience depending upon your client environment and depending upon how your organization has your security set up. So if you're having difficulty with the browser-based sign-in, like you saw with my experience, you can opt to use this use device code option here when you do your AZ login. And what that'll do is it'll return a device code, and then you navigate up to, it'll give you a URL to navigate up to, and then you can punch in the device code to log in. That's sort of a foolproof way of doing it if you're having issues with authentication through your browser. Okay, so what's next? Close that down. All right, so we've done our AZ logout, we've done our AZ account clear, we've done our AZ login. We forgot to change our directory. Let's do that. Now remember, all these folders are different configurations. Right now we're working on VNet shared. So we're in the right directory now. And we've set our default subscription. Now, the next thing that we're going to do is we're going to set up an environment variable called tf_var arm client secret. And I'll explain why we're doing that in a second. So this naming convention, tf_var, is a special naming convention just for Terraform. And Terraform will scan your environment variables, and if it finds any environment variables that start with this tf_var_ prefix, it will then go and configure the value of this variable, in this case arm client secret, to and it'll get that from the environment variable. So this is a way that we can avoid hard coding the password or the secret for the service principal in our code. Okay, so I'm going to just backspace over this. We got to replace this your service principal secret. And I'm going to pause the recording briefly while I go get that secret. Okay, I'm back. I got my secret. I'm going to go ahead and paste it in here. And I'll be changing that shortly for any of you enterprising folks who might try to get into my service principal. And so we've done that step. We've got our environment variable set up. So if I do an echo $tf_var_arm client secret, there it is. We've got our environment variable configured. So it's basically sitting in memory instead of, being in some configuration file, which it's just a bad security practice to put secrets in files like that. Okie dokie. So let's go back and to our docs and see what's next. All right, what's next is we're going to run Bootstrap. And Bootstrap is the first piece of code that we run that provisions a bunch of stuff in Azure that are prerequisites for applying our Terraform configuration. And I'll do a code walkthrough of Bootstrap later. So the way we're going to run Bootstrap is we're going to do, now if I expand VNet shared here, you can see here's Bootstrap, right? So if you want to look at the code, it's right here in VS Code. Like I said, I'll do a code walkthrough of this later. We'll just maximize our terminal here so that we can keep an eye on what Bootstrap is up to. So if I do an LL, you can see here all the same files that I'm seeing in my directory listing show up underneath this VNet shared file, right? That's what we would expect. And we see Bootstrap here is an executable. I've got execute rights on it. You can tell by these X's over here that it's executable. And also this green shading in Ubuntu is a tip that it's executable. That means I can dot source this script. I can pull it into my current shell and run it. So let's go ahead and run it. So first thing Bootstrap did was go collect a bunch of information about our runtime environment. And now it wants the app ID for our service principal. So I'm going to pause the recording and I'm going to go get that. Okay, I'm back. I've got the app ID for my service principal. There it is. And a quick pause so I can answer the phone. Okay, back from my pesky phone call. So I've pasted in the app ID associated with my service principal. And this object ID is the object ID that's associated with the Azure Active Directory user that I logged in with. And it's automatically populated here based upon the user that I did AZ login with. This is the default subscription that we set up. You can see up here, it's the same subscription ID. So that's the piece of automation that relies on the default subscription. But from this point forward, everything will run against that subscription. This is the default name for our resource group for the sandbox. If there's multiple people doing it, you can change it to 01, 02, 03, whatever you like. This is the default region that I use. You're welcome to change the region. Just keep in mind that each region has its own set of services and capacity. So, sometimes the services or the capacity that you need might not be in every region. So just keep that in mind as you move around and try out different regions. This is just an environment tag that I add, a cost center tag, and a project tag. Those are just all three ARM tags. Now here's the default address space that we use for VNet shared, that 10.1.0.0/16. Here is the address prefix for the Azure Bastion subnet, as well as the address prefix for the Active Directory Domain Services subnet, which we discussed earlier. And that is going to be associated with the NIC on the Active Directory Domain Services virtual machine that we deploy as part of this configuration, which also functions as a DNS server. This is going to be the default domain name we use, mysandbox.local. Again, that's not a registered internet, routable domain. And this is going to be the name of our domain controller virtual machine, ADDS1. This is the default admin username that we use across all configurations. So typically you would use multiple different, credentials there for different services. We've simplified it down to one for the sandbox so that you don't have to, fool around with multiple user accounts and passwords. And then the last question is whether or not we want to skip password generation. Since this is the first time we've run Bootstrap, we do not want to skip that. If it was a subsequent run, then we would want to skip it because we wouldn't want to reset the password to something different than we used to deploy the sandbox. Okay, so I'll say no here, and here we go. Bootstrap found the service principal in the subscription. It's created our resource group. Now it's creating a key vault. And now it's creating some access policies for that key vault and setting up some secrets in the key vault. And it's creating a storage account next. Okay, our storage account's created. And it's saving some of the secrets for the storage account into our key vault. It's creating a container, and we're done. Bootstrap is done. So these are all things that we needed to provision outside of Terraform to avoid circular dependencies. And you'll notice whenever you run one of my Bootstrap scripts, the final output is always this terraform.tf-vars file. So what is that thing? Let's look at it. Basically, it's a list of variable names and values, right? So these are all the values that we collected either interactively from the user or using automation after things were provisioned, okay? And these variables are all actually defined over here in variables.tf. So if you look at variables.tf, anything that doesn't have a default like this, you have to set the value somewhere, right? So like ADDS domain name, for example, we need to set the value of that variable. How does that get set? It gets set by looking at the terraform.tf file, and here's the actual value for ADDS domain name. So the variables are defined in variables.tf. Anything without a default is populated using this terraform.tf file that we generate using our Bootstrap script. All right, so let's check out what's next. We've run Bootstrap successfully. So the next thing we're going to do is apply our Terraform configuration. So there's a few commands listed there. So let me maximize this and clear the screen out. And we'll do a Terraform init first. And what this does is it checks your configuration to see which Terraform providers are required to provision or apply the configuration. So you can see here we're using two different providers, the Azure RM provider and the random provider. And those are both defined here in this common.tf. Here's our Azure provider and the version that we're tested against. And here's our random provider and the version that that was tested against. So we're locking in on those versions to make sure that, we can have predictable behavior. Okay? So there's our Terraform init. Now the next thing we're going to do is a Terraform validate. And what that does is it checks to see if your configuration is syntactically correct. And it is. There's no syntax errors in my configuration. That doesn't mean it will provision successfully. It just means there's no syntax errors. All right, so the next thing we're going to do is a Terraform plan. And what this does is it takes your configuration, it compares it to Azure, and then it figures out all the different things that need to be provisioned and how they should be configured. Okay, and what we can see here is that if this plan that we just generated would provision 29 new resources in Azure. It would change nothing and it would destroy nothing. Very important always to do a plan first, because remember, Terraform can version your infrastructure. So when you make changes to your configuration, Terraform will fix up whatever is up there in Azure to be consistent with your configuration, including changing things and destroying things if they no longer exist in your configuration. So you want to make sure you do a plan first so that you completely understand what's going to happen if you do the next step, which is Terraform apply. Now this basically creates the same plan. And we should see that it's going to add 29 resources. Okay, yes, 29 resources will get added. Okay, so it's asking us to confirm. I'll just type in a yes here. And off Terraform goes. The first thing you can see that it's doing is generating a bunch of random IDs, so we don't have to come up for names for everything. And it's starting to provision a bunch of stuff, and including an automation account, a log analytics workspace, a virtual network, and some subnets, and the network security groups and rules associated with those network security groups. And then it's also going to provision our Windows Server virtual machine that we're going to use as a domain controller. So we'll just kind of like watch this output. Now, when you're watching this output, if you see local exec, what does that actually mean? Local exec means that that's a provisioner. So that's a script that is set up to run after a resource has been provisioned, but before it's marked complete by Terraform. So you can see with the automation account that was provisioned that there's a script that's running after that, a provisioner script that's configuring that automation account. Um, HashiCorp is not crazy about provisioners because they can be buggy and they're difficult to support, but they are kind of an invaluable tool if you want to do all of your automation in a single pass. So, you would develop your provisioner script outside of Terraform, fully test it, and then you can call it from within Terraform as a provisioner. And we'll go through some of that in the code walkthrough later. Okay, so now we're down, like most everything has been provisioned except for the automation account. Now, one thing that you should know about Terraform is it can reason all the dependencies. So it will create all as much in parallel as possible in a multi-threaded way, based upon the dependencies that it discovers in your configuration, right? So that it makes it very smart. And you can imagine there's a nice performance benefit there in terms of provisioning things in parallel, versus, if you wrote some sequential script to do things, you'd have to wait for every single thing to provision to go on to the next one, or build your own multi-threading, which is complicated, right? Terraform kind of takes care of all of that for you. So the two resources that are taking a while to provision are the automation account and the Bastion host, and that's expected. It takes roughly 8 minutes or so for those resources to provision. So, all right, the automation account, all the modules have been configured, and we've set up a bunch of variables in the automation account using that provisioner script, some credentials that it's going to use to authenticate, and now it's importing and compiling a desired state configuration file, which we're going to use to configure our domain controller with the domain and all that stuff. So that has to be compiled before it can be applied to the VM. All right, that compilation job is running now. It's collected all its binaries. It's creating what desired state configuration would call a MOF file, which includes all the binaries that need to get pushed to the VM that's being configured. And the compilation job completed. So that's a prerequisite to deploying the VM. So now that that's completed, the automation account is finally all configured, and we can move forward with provisioning our virtual machine. And you can see here the virtual machine provisioning process has started. And the Bastion host is also still provisioning. That has probably 2 more minutes to go. So this will probably take about 10 minutes or so. So I'll likely pause the video and pick back up when there's something new happening. Oh, that's a good point here. The subnets that are required to provision both the Bastion host as well as the VM have network security groups associated with them. So you can see those being set up here. It looks like the Bastion host has successfully deployed, which is cool. Now we're just waiting for the Windows Server VM to provision. Now the VM's provisioned. The next thing that's happening here is this provisioner script is running, and it's going to register it with desired state configuration, which is going to push that configuration that we just compiled down to that VM, and it's going to configure it to be a domain controller. And that'll also, you can see that warning there. This process can take several minutes. The VM will be rebooted. So definitely going to go away for a little while now and wait for that process to complete. All right, I'm back. Terraform successfully applied the configuration, and all our 29 resources got created. You can see here the The VM, our Active Directory Domain Services domain controller, took about 7 minutes and 44 seconds to provision. And then Terraform also tells us all the different output variables that are part of the configuration and what their current values are. And those output variables can be used to drive other configurations that have a dependency on this one. So yeah, I think we're good to go here. Let's see what else the documentation wants us to do. Okay, we see here we did get 29 resources added, and it just says now let's inspect the state file. So this is something that's unique about Terraform. You'll notice there's a new file here called terraform.tfstate. And that state file is what tells Terraform what's currently provisioned. And the state file can be inspected with a few different commands. So we can do a Terraform state list. And this will be the list of 29 things that got provisioned when we applied this configuration. Okay, and the state file will include all the different properties that Terraform knows about with regards to each of these resources. And then the other thing that's in the state file is the output variable. So if I do a Terraform output, there's a list of all the different output variables and their current values. Again, we can use those to drive automation for other configurations that have a dependency on this one. Now that state file is just a JSON file, and it typically should be stored in a secure location because it does have secrets in it. So you will want to, when you use Terraform in production, store it in a backend is what Terraform calls it, state backend. So for Azure, you can use Azure Storage as a state backend, and the state file will be managed there. And it will be encrypted, and you'll be able to lock it down so that it's not just floating around on somebody's hard drive, right? So you definitely want to secure that for production usage. I think that's it for this section, which is getting started. So we'll pick up with smoke testing next.